Hello, Algebra 2 Advanced. This lesson, Chapter 1.6, is all about solving linear inequalities. Before I go any farther, let me just say I'm going to hit only the highlights of this chapter. I recommend that you read the chapter. I always do that, but in this case in particular, the one concern I know that most of us feel like inequalities is a subject we've studied so many times that we don't really want to look at the number line ever again. And in fact, I still, every year, see a number of kids who are confused about how to work with the number line when they get to negative numbers and inequalities with negative numbers. So I recommend that you do read the chapter and make sure you're clear on that. I'll point something out one time in this lesson, but otherwise I'm just going to hop right past that topic. Speaking of the highlights, there are 4 types of linear inequalities that you're going to need to be able to solve. First of all, sometimes the variable has a positive coefficient. It's a different story when it has a negative coefficient, and we have a different approach for that. Sometimes we have what we call compound inequalities. Sometimes those compound inequalities are what we call and inequalities, and sometimes they are what we call or inequalities. We'll learn how to solve each of these 4 types, starting with this first one. Positive coefficient. Okay, well the coefficient on this x is positive. It is a fraction, but it's positive. Solving this is a lot like solving if this had been an equation instead of an inequality. I'm going to want to move the 4 over, I'm going to want to move the half over, and I've got to do it in the opposite order of PEMDAS. That means I move the 4 first. So now I've got a half x left on the left and 3 on the right. I want to get rid of that half. I could divide, but I'd rather multiply by the reciprocal. So now on the left I've got x, which is what I want, and on the right I've got 6. X is less than or equal to 6. I can always double check and make sure that answer is correct. I can plug 6 into the original inequality. Let's look. A half times 6, well that's 3. 3 plus 4. Is that really less than or equal to 7? Yes, 3 plus 4 is 7, so 7 is equal to 7, and I'm allowed to have equals. Now I can double check the number above and the number below 6 just to make sure that I really have the dividing line and I have the arrow going in the correct direction. So the numbers below 6 should work, so 5 should work. Half of 5, 2 and a half. 2 and a half plus 4, 2 and a half plus 4, that's 6 and a half, and 6 and a half is less than 7. Numbers above 6 should not work, so 7 shouldn't work. Half of 7 is 3 and a half. 3 and a half plus 4 is 7 and a half, and sure enough, 7 and a half breaks this inequality. 7 and a half is actually greater than, rather than less than, 7. All right, your turn. Go ahead, hit the pause button, and when you come back, I'll show you the solution to this one. Okay, I'm going to assume that you did that, and here's that solution. If you want to, you can hit the pause button again, and you can look at each of these steps and make sure that you understand why y is less than 4. If you have any questions about this afterwards, bring them to class, and we'll talk about it. All right, moving on to the second scenario. Like I said, when it's a negative coefficient, the story's different. I highlight this point here, switch the arrow. You'll see what I mean in a minute. I want x by itself, so I'm going to divide by negative 11. Anytime I either multiply or divide by a negative in an inequality, I've got to switch the direction of the arrow. So now on the left I've just got x, and on the right I've got, well, 77 divided by negative 11 is negative 7. But my arrow has switched direction, so the answer is x is less than negative 7. Why did I have to change that arrow? Well, let's plug some values in for x and see. All right, here's where I said I was going to bring that number line back. Negative 7 is right here. So less than negative 7 is the numbers to the left of that. And I really do have a number of students who get confused about that, so I want to point this out. Negative 8 should work because the solution says it's any number that's less than negative 7. So negative 8 should work, negative 6 should not. Let's try them both. plugging them both into the original inequality. Negative 11 times negative 8 is positive 88, and that is bigger than 77, so negative 8 did work like we thought it would. Negative 6 times negative 11 is positive 66. That's not bigger than 77, so like we expected, negative 6 didn't work. So this answer makes sense. Now, here's your turn. Go ahead again and hit the pause button, and when you come back, I'll have the answer for you. Okay, I'm going to assume that you did that. Here's the answer all worked out. You should have gotten x is greater than or equal to 2. Feel free, of course, to hit the pause button and look at these individual steps if you want. Come to class if you have any questions. Otherwise, we're going to move on. Now, this should say still 2 up here. I have a suggestion. When you get questions where there is an x term on the left of an inequality and another one on the right, and that's true of question 1, that's also true, notice, for question 2. In either of these scenarios, of course you've got to put the like terms together. I recommend that you put them together on the side where you're going to have a positive coefficient. Positive coefficients are just so much easier and less likely to create errors. So I got to move that negative 2 over to the positive side. So now on the right side, I've got 3x plus 1, and on the left side, I've just got 4. I'm not going to have to change the direction of the arrow. I just move the 1's over, and I've got 3x is less than 3. I divide out that 3, and I end up with 1 is greater than x, or x is less than 1. On the right side, I'm going to have you do this, but I'm just going to suggest move the 5x over to the side of the 7x. If you do that, you'll end up with a positive coefficient on x. Now hit the pause button and finish this up. Okay, I'm going to assume that you did that. Here's the worked out solution. You should have found that x is less than or equal to negative 1/2. If you didn't get that, come to class with questions. We're going to move on to the third situation. We start talking now about compound inequalities. The first type is the AND inequality. The way we would say this is 3t minus 8 is greater than or equal to negative 2 and it's less than 10. That's why we call it an AND inequality. AND inequalities always have the variable in the middle of two arrows that are both going in the same direction. Now, the textbook just shows you how to solve this in a few steps. First of all, they say move the 8 out of there so that you are getting 3t by itself. When you do that, you'll find that on your left you now have 6, and on your right you now have 18. The most common mistake I see students make with compound AND inequalities is they just move this 8 to one side or the other, whichever is their favorite. You can't do that. You've got to treat both sides the same. So I've now moved 8 to both sides. I've got 3t still in the middle, but I've got changes to the left and right. Now I divide both sides by 3. And on the left I end up with 2, and on the right I end up with 6. So t is greater than or equal to 2 and less than or equal to 6. Again, that's why it's called a compound AND inequality. And this is the final answer. Now it's your turn. This is a little bit more challenging, so I'm going to show you the steps in a few minutes, but go ahead and try it yourself. Okay, I'm going to assume that you hit the pause button, solved this, and are ready to see the answer. I'll break this out step by step. I've got to get x by itself, but first I've got to move the 2. I can't do anything about this negative sign until afterward. So now on the left side I've got negative 6, on the right I've got 4, in the middle I still have negative x. I want positive x, not negative, so I'm going to divide everything by negative 1, which means the arrows change direction. And now I've got 6 is greater than x, which is greater than negative 4. I'm okay if you give me this as your final answer. Some teachers won't accept it. Some prefer the conventional way where all the arrows flow to the left. And I understand that, and I would prefer it too, but I'll accept either of those. Both of those are fine. The only thing I'll say is don't give me an answer where you have arrows pointing in opposite directions, either both pointing in toward the x or both pointing out away from the x. If the arrows are in opposite directions, I'm going to give it back to you with an error. Okay, let's talk about the compound OR inequality. These are actually much easier to solve. The only challenge is you've got double the work. So essentially what you do is you split it in half. What this says is that 1 minus 2x is less than negative 3, or 3 minus x is greater than 5. Well, that means I've got to figure out what happens over here and also what happens over there. So I got to solve the left. I got to get x by itself ultimately. The first thing I'm going to do is move the 1. On the right side, I've also got to get x by itself. The first thing I'm going to do is move the negative 3. So on the left in blue, I've now got negative 2x is less than negative 4, and you can see what I have on the right in purple. Now on the left, I'm going to have to divide by negative 2, which means I'm going to have to change the arrow direction. On the right, I'm going to have to divide by negative 1, again changing the arrow. So on the left, that's the answer I end up with. X is greater than 2. On the right, I get x is less than negative 2. Remember, these are OR answers. So x could be greater than 2, or x could be less than negative 2. And just like the original problem, you're ending up with OR in the answer because it is a compound OR inequality. All right, last thing. You guys go ahead and try to solve this one yourselves. I'll give you the answers as soon as you've done that. Okay, I'm going to assume that you have. We'll step our way through this too. We have a minute or two to do that. I want to get x by itself on the left. I also want to get x by itself on the right. First thing to do is move the number that is either added or subtracted. So on the left I now have that, on the right I now have that. These are both pretty easy, both the left and the right sides. The only challenge is I've got twice as much work as on those first problems I looked at. So on the left you should have ended up with, oops, come on, x is less than 1. On the right you should have ended up with x is greater than 4. And you should have recognized that the answer is an OR. Both of these could apply. All right, that's it. Just quickly reviewing, the highlights were that there are 4 situations, 4 types of linear inequalities you needed to be able to solve. Sometimes the coefficient's positive, sometimes negative. Sometimes you've got a compound inequality, and in that case it could be an AND, where the variable's in between, and the in between 2 arrows, I should say. And sometimes it's an OR, where it clearly says it's either this or it's that. There's your homework. Go ahead and solve those problems and bring them in, and we'll go over it in class.